So, generating natural expressive speech from text is a constant quest in the AI space, especially if you're looking to build a personal AI assistant or maybe just a local TTS generator where you provide the text and it generates the audio. And recently, there have been a number of really great ones, like really good ones, but most of them requires PC with really beefy GPUs or powerful CPUs plus a VRAM for it to be feasible to use them as the voice of your AI system or just to run them instantly so there won't be much of a latency. So today we'll be setting up a TTS model that's both light and produces realistic speech, and it's called OuteTTS. I think it's by OuteAI. I honestly don't know how this is actually pronounced. It's a weird name, and maybe it's French or something, but it's Aut or Out. I honestly do not know. So I have covered a previous version of this model in a previous video. Like I've covered it on this channel, and I'm going to be dropping the link to that particular video in the description. I think I covered version 0.2. I showed how to actually set it up on the MacBook. So today we'll be talking about the new release, the version 1.0, which was released a few days ago, and they did release two classes of the version 1 model. So they actually released the OuteTTS 0.6b model, which was actually built on Qwen 3, the 0.6b parameter model. So that's what they actually use as the base model. While the other one is the Llama OuteTTS. So this particular model is a 1 billion parameter model, as you can see, and it's based on the Llama 3.2 1B model. That's what they actually used as the base model. Another difference between the both of them is the fact that this one, which is the Llama based model, was trained on over 60k hours of audio data, while this one was actually trained on just 20k. And this one, it actually supports just 14 plus languages, while the Llama based model supports over 23 languages. They have the same context length, as you can see here, which basically I think it's supposed to produce around 42 seconds of audio. I think so. But as usual, in this video, I'll be focused on testing with English, and I'll definitely try out the both of them. I'll definitely compare the both of them in a way, but that will be really brief. But I'll be more focused on the Llama based model since it's more robust, since it's larger, and it was trained on more hours of audio. At least that is the best they could actually do for this particular version 1. And now that all that's out of the way, let's open up our code editor. A quick note, I'll be setting this up on my Ubuntu cloud server, but the setup would be the same on any PC. You can set it up on a Mac or on Linux or just Windows basically. So the setup is basically the same thing. And also make sure you have your virtual environments all ready to go. I have mine here activated, so make sure yours is also activated. You can use Conda or virtualenv. It's definitely up to you. And the Python version I'm actually using is Python version 3.10. That's what I'm actually using for this particular project. Now you could clone your official repo, or you could just install the OuteTTS Python package. But let's head over to your official GitHub repo. I also cloned the repo here. I did that for a reason, but you don't actually need to do that. So let's head over to their official GitHub page. All you need is one of these right here. If you scroll down, as you can see, if you want to run it on a CPU, then you should run this code. Just copy and paste it in your terminal where your virtual EV is actually activated. That's basically your IDE. You open up the terminal and paste it in. Or if you're actually using an NVIDIA GPU with CUDA, you could do this. But if you're using a Mac, a Metal, like the Apple Silicon MacBook M1 or M4 or M3, you could actually just copy this and run it. Our cloud server only has CPU and VRAM, so I'm just going to be copying this and pasting it in the terminal. Now, I've already run this command, but let's just do that again. It's set. Now let's take a look at main.py, the file I created for this particular test. Now the code that's actually in here is in their official Hugging Face repo. Let's head over there. If you scroll down, as you can see, this is the code we are actually using right now. Let's head back to our IDE. Okay, what's actually going on here is really simple. But first of all, let's talk about how to get all this running. To be able to use this particular, you could either download the model weights manually from the Hugging Face page by heading over to files and versions and download all the weight. You can just download all these files, the .json files, together with this one, and also the .savetensor file. So basically everything from here down here. So those are the files you need to download. You can just click on the download button. You could do this manually, place all these files in a particular folder to keep it very tidy, and maybe place a particular folder in your project directory, or you could actually use the Hugging Face CLI package. So to actually install the Hugging Face Hub CLI package, all you need to do is run this command, pip install -Hugging Face _hub CLI. So that's what you actually need to run, and you run that. Now that that's actually installed, if you're using a MacBook, you can just do bring install Hugging Face -CLI, and that should actually work fine for you. That's an alternative way to actually install it if you're using a MacBook. So now that that's actually installed, you can download all the necessary model weights directly. The folder which we would actually use is the model directory, and since we are actually doing that, the command we would actually need to run next is this. That is Hugging Face -CLI. That's basically the command, and the next is the download command, and then the Hugging Face model name, or the Hugging Face repo. And to actually get this, all you need to do is copy this and paste it here. That's the value we actually have here. So if you want to actually do that, you can do that. Now we want this to be pulled into the model directory, which means we want to actually set it up in this our project folder. If you don't actually specify this directory, to automatically send this to your cache directory. So let's hit enter. So as you can see, it has actually created a folder with all the model weight and the config files. Another thing we're going to be doing is trying out the quantized version, that is the GGUF version of this particular model. And if we head back to the Hugging Face page, and as you can see, we have the quantized version, GGUF. If you go over to files and versions, as you can see, these are the files, but we won't be downloading all the files. We'll just pick a specific one that we actually want. So we'll be going for Q8 because we want it to be way more accurate. We won't be going for Q4. We'll actually be going for Q8. As you can see, it's just 646 megabytes compared to the safe tensor. If we head back here, as you can see, the safe tensor here is 1.2 gig, so it's half of that. And since we'll be using Llama CPP, it should run really fast on our CPU. And we're going to be saving this GGUF quantized version in a GGUF directory. It will automatically create the GGUF directory, but let's paste in the command. As you can see here, we're saying Hugging Face CLI using the download command, and the next thing is the model name, or let's say the name of that particular Hugging Face repo. And the next thing we're going to do is download a particular file. Now you have to actually specify the file. If you want to download multiple files, all you need to do is give a space and type in the name of the file. Let's say we want to download the Q4. You can then paste in. Let's just do that. We're going to paste that in, and we'll go for Q4. You actually spell it right. And the local directory we're actually going to download this to, or pull this to, is the model/GGUF. So you should automatically create a GGUF directory under the model directory. So let's hit enter. As you can see, we have our GGUF directory. So since we'll be more focused on the Llama model, let's pull that particular model, and we're going to be saving it in the Llama directory. It would actually create the model/Llama. That's where we'll be saving it in. Let's hit enter. As you can see, we have all we actually need here. And to get the quantized version of this model, and we'll also be downloading the Q4KM. So let's copy this. So we'll hit enter. You should save it in llama/gguf. Well, I think it's best to just save it in /gguf. It's way more cleaner. So we'll have everything in one spot. Let's hit enter. So we'll find all our GGUF quantized version here in the GGUF directory. Now that we're done with all that, let's go over main.py. The code is really short. Just 28 lines. As you can see here, we have our imports, we have our interface, model config, generation config, the backend interface version, the models, the generation type. Now, this first line or this first segment, we're actually initializing the interface. Here we can pass in a custom model config, or we can use the model config auto config. Since we're actually doing it like this, it will automatically download the model from the Hugging Face Hub and it save it in our catch directory. That's what this is going to do if you do it this way. And this option for the backend is if you want to actually use the GGUF quantized version, you have to change this to Llama CPP. That's a different backend. Because if you look over here, let's go over to the OuteTTS, which we actually cloned. If we head over there, as you can see, the different backends we have HF, we also have Llama CPP. So if you want the GGUF quantized version, then you can actually go for .llama CPP instead of the HF. So right here, what we're doing is loading the default English speaker profile. This particular model only has one default speaker, like it only has one speaker. So if you want to actually create your own speaker profile, you would actually need a WAV file. You would actually need to uncomment this line of code and comment this out. So as you can see, the first thing you're going to do is pass in the WAV file, which you want to actually clone. And then right here, we're actually saving the speaker.json. It will save it to wherever you want. As for this particular line, it's saving it to our root directory if we actually run it. But make sure you actually pass in the path to your audio file that you want to actually clone. And in this particular video, we'll actually be cloning three voices, my own audio file and Jarvis and Optimus. Those are the three we'll actually be trying out in this particular video. So now, once you've actually done this, you do not need these two lines to run it anymore. Like, you do not need these two lines. Since you've generated your speaker.json, you can just load the speaker from this save file. Like, you can load it from the speaker.json instead of doing all this transcribing using Whisper and then generating the speaker profile. Once you've done it once, you don't need to do it anymore. So you can easily load your speaker, but just with this line once you've actually generated it. Then right here is where we would actually generate our audio from the text. We'll pass in the text and then our speaker profile. And here we're actually saving the output. So anyways, this is what you can actually use if you want it to be downloaded automatically to your catch directory. You can use the auto config. But since I don't want to do that, since I have all my model weights in the model directory, then I'm going to do something else. Let's head back to the OuteTTS GitHub repo that I just cloned, and we'll head over to docs and interface. So let's view this properly. And since I don't want to use the auto config, I can get the custom configuration. As you can see, this is the custom configuration. I can paste it in now. All I need to do is, since the first model that we'll actually be trying out is the normal, the one that's actually based on Quen 3. Since that's what we're going to be testing first, let's make sure our model path is pointing in the right direction. Okay, we have it here in the model directory. That was the first model weight we actually pulled. So all we need to do is pass in the model path. And since we have the tokenizer path in the same place, we have the tokenizer in the same place, these are the two of them, we can just do the same thing here. And we're using the interface version 3, that is since we are actually using the version 1. So as you can see, version 1 is for the version 0.1 models, and version 2 is for version 0.2 and version 0.3 models. And since we are actually using the version 1 models, that's why we're having it set to version 3. And for the backend, we're actually using backend.hf. Let's change this since we already imported backend here. So let's use backend HF since we're using the Hugging Face transformer model. So we do not need to actually use flash attention. We would also be using CPU. So everything looks good. So let's comment this out and let's uncomment the default speaker. We are going to be using the default speaker first, and we're going to generate this audio output or wave, and the text would be hello, how are you doing? So let's run the code. We're going to run Python and let's Sorry, we actually forgot to do something else. We forgot to take this out. Since we've actually imported interface version here, we do not need to. Let's run it again. I also missed importing torch. Let's import torch. That's something that's actually important. So let's run it again. And as you can see, it's loading up the model, and once it's done, it generates the audio to output a wave. Now let's check it out.
Hello, how are you doing?
Sounds really, really good. That actually sounds really good. Okay, as you can actually see, it actually works really well. Now let's try the llama model. Let's add in an extra text. And this time we're going to point it to the llama directory. So let's run the code again. Okay, that's actually done generating the audio, output.wave.
Hello, Austin. How are you doing?
That's good. That's really, really good. And it's consistent, same voice. So that's actually really good. It generated the female speaker over again, like it actually generated the same voice, which is cool. Sometimes when they actually release these models, they actually hype it up that it actually has a default speaker. Sometimes it's not actually consistent, but for this particular test, it's actually consistent, and that's cool. So you can just use this default speaker without going into the voice cloning. But for this video, since we would actually be talking about the voice cloning, let's dive in. So the next thing we're going to be cloning is Jarvis or Wave. That's the first one we're going to be cloning. We're going to be generating the speaker JSON. That is, we'll be generating the speaker profile and we'll be saving it. So let's point it in the right direction. Okay, that's good. So let's run the code now and hear how it actually sounds. But one thing it's going to do is it's going to download Whisper. Since we're actually doing this for the first time, as you can see, it's downloading the Whisper model because that's what it will use to transcribe it. Because for voice coding, most of these models actually do require a transcript, and this one actually does it automatically for you. But you can actually pass in a transcript. You can do it the old way and pass in a transcript. I think so. As you can see, you can pass in a transcript like it's done here. But you can also choose the Whisper Turbo model. But it's actually done. It has pulled it and it will start transcribing it. As you can see, it has transcribed it. And now it will generate the speaker profile. Since it has actually done that, it will start generating the audio for you. So let's wait and see. Okay, now that's actually done generating, let's play it and hear how it actually sounds.
Hello, Austin. How are you doing?
Not bad. Let's play Jarvis or Wave so you would hear what it sounds like.
Accessing alarm and interface settings. In this window, you can set up... Hello, Austin. How are you doing?
Not bad. Not bad. It's not really bad. Since it's actually done generating the JSON, what I'm gonna do is add in extra text. Now we're going to comment this and uncomment this. So we're going to be using the already saved speaker profile. Now, as you can see, we have the speaker.json in the root directory. So let's run the code. So it shouldn't do the usual transcription, which means it won't actually take as much time as it did earlier. Okay, it's done generating the audio. Let's play it.
Hello, Austin. How are you doing today? I hope everything's going great.
Not bad. It actually has a British accent because it's Paul Bethany that actually voiced Jarvis. So that's really cool. Okay, the next thing we're gonna do is we're going to clone Optimus. But this time we're gonna be using the GGUF quantized version. Okay, let's change this to Optimus and we're gonna scroll up. This time we're gonna be pointing the model path to the GGUF file. We're going to be using the llama. So head over to the GGUF directory and we're gonna be using this one. Let's try the Q4 and see if it will actually do a really good job. And as for the tokenizer path, we're going to leave it pointing to the same place. Since we're actually using the llama-based OuteTTS model, we would actually leave the tokenizer path pointing in the same place because the files will actually require are found there. Like for the tokenizer path, we actually do require these two files, the tokenizer config and the tokenizer.json. And since they're actually found in the model/llama directory, we're going to leave this pointing towards that particular place. And next thing we're going to do is change the backend to llama cpp. So we're going to do, and we're going to add something else. We're going to add in quantization. That's what we're going to add in, but we'll have to actually import llama cpp quantization. Let's see if it's imported. If it's not, we would actually have to import it. And the quantization we'll actually be using, since we're actually using Q4KM, that's what we're going to be passing in here, Q4KM. Because if we head over to info, let's see, as you can see, we have the llama cpp quantization, and the ones that are actually available Q4, we have Q4KM, as you can see here. So that's what we are actually passing here. Okay, since everything looks good, we are passing in Optimus the wave. Okay, hello Austin, everything looks good. Now let's run it and actually hear how it actually sounds. As you can see, it's using llama cpp. And another quick note, for the audio file, make sure that the audio file you want to actually clone is, I think the maximum is 20 seconds. So make sure you actually trim your audio to be at most 20 seconds long. Okay, we have output.wave generated. Let's play it.
Hello, Austin. How are you doing today? I hope everything is going great.
So let's play Optimus the Wave and hear how it actually sounds, because this is weird.
And just when all hope seemed lost, message of a new discovery drew us to an unknown place. Hello, Austin. How are you?
It's not far off. It's not really far off. So what we're gonna do next is try using the speaker profile which we generated for this particular GGUF contains version. So let's just try it, because I want to see if the speaker profile it generated was any good. But anyways, it's still basically the same thing, because it's used as it saved it actually used the speaker profile. That's what it actually used to generate the audio. So but let's just see. Okay, let's run the code again. So it shouldn't take as long as it did earlier. It should just start generating the audio rather than transcribing. Okay, it's done generating output or wave. Let's play it. Let's hear how it sounds.
Hello, Austin. Is today your birthday? I hope everything is going great with you.
Not bad, not bad. Not bad. So Q4KM actually does a really good job. But let's try Q80, because we did pull that particular model, Q80, as you can see it here, so we can definitely use it. And let's run it, but this time I think what we're gonna do is, let's generate a new speaker profile for it, so we'll see if it actually does a much better job than this. Okay, it's done generating the output, the wave audio. Let's hear it.
Hello, Austin. Is today your birthday? I hope everything is going great with you.
Okay, now that we've done all that, the next thing we're going to be trying out is cloning my own voice. But this time we'll be switching over to the Quen-based model. So we're going to compare my voice being generated by this model first, this llama-based model, and then we'll compare it with the one generated by the Quen-based model. So let's first pass in Austin the wave. Let's see, and this time we won't actually be using the llama cpp backend. We'll switch back to HF for the transformer model. So we'll be taking off this. Let's just comment that. So everything looks good. Now the first audio says, since this is the llama, let's add llama, because we'll be comparing the both of them, and we don't want the next one which we will actually generate to actually replace this one. So let's run the code. Okay, it's done generating. Let's hear it.
Hello, Austin. It's today your birthday. I hope everything's going great with you.
Okay, this is the one I actually recorded. Zonos is a really great model by Zifra, and they believe that Zonos generation quality. So, and this is what it actually generated.
Hello, Austin. It's today your birthday. I hope.
Since we will be comparing it with the other model, the Quen-based model, let's switch this back to model. Okay, now we can actually run this again, and hear it actually sound. But this time we'll be changing this to Quen. Okay, it's done generating the audio for the Quen based OuteTTS model. So
Hello, Austin. It's today your birthday. I hope everything's going great with you.
that was horrible. Let's try again to see if maybe it can actually do better. Let's try again. Okay, it's done generating the audio.
Hello, Austin. It's today your birthday. I hope everything is going great with you.
Much better than the previous one. It generated at least much better than the previous one. But let's replay the Llama version. Let's play it.
Hello, Austin. It's today your birthday. I hope everything's going great with you.
Yeah, they're both weird. There's not much of a difference between the both of them that I could actually hear, but you can actually leave a comment if you think one is better than the other. You can just drop a comment. So that's all I've got for this particular video. And like I said in the beginning, if you want a very good text-to-speech model, then you can actually try this out. If you want to do just text-to-speech, you'll have one default speaker. But for the voice cloning, I think they're not there yet. I think they're not just there yet, in my opinion. And I've been waiting for version 1, but I'm surprised they are not actually there yet. Like, it's not as good as something like Fish Speech or a previous model which I just tried out. So I'm going to be dropping a link to Fish Speech in the video description. If you're looking for something that actually does really well at voice cloning, you can actually try it out. Or Cozy Voice, that's a really good voice cloning model if you're just focused on the voice cloning part. But for those people that want to actually just use it for a simple text to speech, then this model is really good at that, especially generating the default speaker. You can play around with the sampler config, the sampler configuration, which we actually have here. You can just play around with it and see how well it actually does. But if you want something way more lightweight than this, you just want something with way more speakers, then you should definitely try OuteTTS. I'm going to be dropping the link to that particular video in this video description because I also released a video about that a while ago. So you can actually check that out. That is also very realistic and it has lots more voices than just one default speaker. So you can actually check that out if you want a much more lightweight text-to-speech model. So make sure you do like, subscribe, and do not forget to hit the bell notification icon if you want to get notified when I actually release a new video on this channel. On this channel, we cover everything tech, everything that has to do with AI, especially coding and product reviews. So if you love content like that, do not forget to subscribe and hit the bell notification icon. Thanks for watching. Have a nice one.